Hello everyone, welcome to Red Shikshan Sanstha's Western Region English Medium Schools. Today we are going to study subject Science and Technology 1, lesson name Periodic Classification of Elements, Standard 10, video number 8. Before learn the new point, we are discuss about the previous knowledge. While going from top to bottom within any group, one electronic shell get added at a time. From this, we can say that the electronic configuration of the outermost shell is characteristic of a particular group. However, as we go down a group, the number of shells goes on increasing. While going from left to right within the period, the atomic number increases by 1 at a time and the number of valence electrons also increases by 1 at a time. In the modern periodic table, electrons are filled in the same shells. While going along a period, from left to right at the beginning of the next period, a new electron shell starts filling up. Now we are going to study electron capacity of electron shell. Before that, we are discuss about the can you recall. What are the values of N for the shells K, L and M? The values of N for the shell K, L and M are 1, 2 and 3 respectively. What is the maximum number of electrons that can be accommodated in a shell? Write the formula. The maximum number of electrons that can be accommodated in the shell is 32 electrons and the formula is 2n square. Deduce the maximum electron capacity of the shell K, L and M. For the shell K, the maximum electron capacity is 2 electrons. For the shell L, the maximum electron capacity is 8 electrons. For the shell M, the maximum electron capacity is 18 electrons. Now we are going to study electron capacity of electron shell. The electron holding capacity of shell 2 elements are present in the first period and 8 elements in the second period. The third period also contains only 8 elements due to the law of electron octet. Here is a chart. There are quantum number of designation. It is denoted by small n and the shell capacity and the formula of shell capacity is 2n square. So the first shell electron capacity is 2 into 1 square is equal to 2. The second shell capacity 2 into 2 square is equal to 8. The third shell capacity 2 into 3 square is equal to 18 and fourth shell capacity 2 into 4 square is equal to 32. The chemical reactivity of an element is determined by the number of valence electrons in it and the number of shells, valence shells. The information of these points is obtained from the position of the element in the periodic table. That is, the modern periodic table has proved useful for the study of element. Here is a diagram. In the middle there is a positively charged nucleus and around the nucleus there are 4 shells. K shell, L shell, M shell and N shell. This is the diagram. In the shell capacity, the electron holding capacity of the K shell is 2 electrons. The electron holding capacity of L shell is 8 electrons. The electron capacity of M shell is 18 electrons and the electron capacity of N shell is 32 electrons. Now we are discuss about the periodic trends in the modern periodic table. When the properties of element in a period or a group of the modern periodic table are compared, certain regularity is observed in their variations. It is called the periodic trends in the modern periodic table. The periodic trends in only 3 properties of elements, namely valency, atomic size and metallic and non-metallic character. Today we are going to study about the valency. The valency of an element is determined by the number of electrons present in the outermost shell of its atoms, that is the valence electrons. Now we are discussing about some questions. What is the periodic trace in the variation of valency while going from left to right within a period? Explain your answer with reference to period 2 and period 3. In a period, change in valency of elements varies electronic configuration. The number of valence electrons is different in these elements. However, the number of shells is the same. In a period, while going from left to right, the atomic number increases by 1 at a time, and the number of valence electrons also increases by 1 at a time. In period 2 and 3, while going from left to right, valency varies. The periodic trends in the variation of valency of period 2 and 3. Here the period 2 and period 3. The elements of period 2 are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. There is atomic numbers also given here: 3, 4, 5, 6, 7, 8, 9 and 10. The atomic number increases by 1 at a time, and the number of valence electrons also increases 1 at a time. So, change in valency of element varies electronic configuration. The number of valence electron is different in these elements. However, the number of shell is the same. In the period 3 also, there are elements sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. And the atomic numbers are also increases by 1 at a time: 11, 12, 13, 14, 15, 16, 17 and 18. The number of valence electron also increases by 1 at a time. And in the period 2 and 3, while going from left to right, the valency is varies. For period 2 and 3, on going from left to right, the valency is increases and it is varies. Now the second question is, what is the periodic trends in the variation of valency while going down a group? Explain your answer with reference to the group 1, group 2 and group 18. All the elements in group have the same number of valence electrons. Therefore, elements in same group have same valency. For example, the elements of group 1, hydrogen, lithium, sodium, potassium, etc. contains only one valence electron. The valency of element of group 1 is 1. Similarly, for group 2, beryllium, magnesium, calcium contains two valence electrons in their valence shell. The valency of element of group 2 is 2. The elements of group 18, neon, argon contains 8 electrons. Exception, helium contains 2 electrons. Since the octet is completed, their valency is 0. Here is a group 1, group 2 and group 18 elements. The hydrogen, lithium, sodium and potassium contains only one valence electrons. The valency of elements of group 1 is 1. Similarly, for group 2, beryllium, magnesium, calcium, the valence electrons are 2. So, the valency of element of group 2 is 2. Then group 18. In the group 18, the elements are neon, argon contains 8 electrons. Exception is helium. Since the octet is completed there, so the valency is 0. Thank you. Thank you.